Thanks. Yeah, happy to be here, and thanks everyone for being here. So I'm going to talk about NLP for users from diverse cultures. So let me start with. Sorry, let me just hide this thing. Okay, so let me start with a motivating example. So in this example, I told ChatGPT this made-up story. Mike and Emily had a delightful dinner in a restaurant in Madrid. The bill was 96 euros, so they put a 100 euro bill on the table and left the restaurant. What might Mike and Emily's 4% tip say about them? And then ChatGPT says that they're either frugal on a tight budget or that they didn't like the service. So obviously it's applying the North American norm of tipping, like at least 15 or maybe like 25% in some places, and completely ignoring the fact that this happened in Spain, where tipping is optional and considered not very common and would be considered polite and like thanking for an exceptional service. So this is an example from last year. I actually did try it again recently, and continuing the like non-reproducible and non-scientific progress in NLP from Frank's talk. Now ChatGPT does get it right and like cites correctly explains that tipping is culture specific, which is not super surprising if you think about that, because the web is full of like tipping guides, so it should have learned that from somewhere. This is like one example where that shows that English language models have North American bias, and I'm going to show some other examples throughout this talk. So why does this happen? It's actually not really surprising if you think about, first of all, the source. So the source of the bias is the training data. So even if you look at language models that are multilingual, like ChatGPT or GPT-4, you can speak to them in other languages as well. But the internet is still predominantly English. So as of January 2023, 59% of the websites were in English. So even multilingual language models are still dominated by English. And if you're looking at language models developed separately for different languages, for lower resource languages, the language models would not be of high quality. And so a lot of people end up using the English language models because there aren't any, or the models in their native language, or because the models in their native languages are not that high quality. And then if you look at the source of the training data for the English text on the web, so statistically it would mostly come from the US, because the US has 300 million English speakers compared to other English-speaking countries that have much fewer than this. So eventually what we get is that these language models, they learn about the world from a collection of English texts that are written by mostly US-based users. And so they develop this narrow Western, North American, or even US-centric lens. A similar phenomenon is encountered when in text to image generation models. So this is an example from Bing or Copilot, whatever they call it now. So I asked it to generate an image of a breakfast, and then all 4 images that are generated here are they include like eggs, bacon, pancakes. So it's very Western again in its nature, and it's also not surprising because most of the images that I was trained on, most of the images it was trained on come from like Western countries. So what are the risks from this North American bias? So first of all, culture plays a significant role in shaping our communication styles and worldviews. In cross-cultural interaction between people, there could sometimes be misunderstandings because of that. And so a similar thing can happen when a user from a non-Western or non-North American culture interacts with an English language model, and they may feel misunderstood or experience that the model is less helpful. To be better understood by AI tools, users may actually adapt their communication styles. So that's kind of similar if you think about how some people with foreign accents would like Americanize their accents to be understood by Siri or Alexa. So it's a similar phenomenon. And then in addition, as more people use large language models for editing their writing, they're over time likely to unify the way that we write. So over time, we run the risk of raising some cultural differences. And then the last point is maybe the more risky one, is that as LLMs are increasingly used for automating processes that make decisions on people's lives, like, for example, resume filtering, then one can imagine that this North American bias, which is baked into these models, could actually end up resulting in discriminating against people from different cultures. So I will talk about a few projects that we're working on with the goal of mitigating this bias. One of them is complete, the other one is like almost complete, and then the third one is mostly like future work. So I'll start with the first one is about teaching common sense models about cultural concepts and traditions. The second one is a new data set for image captioning from diverse cultures. And the last work, the future work, is about more about cultural norms. So let's start with the first one. In this work, we focused on Comet. So for those of you who don't know Comet, I'm actually going to show it through a failure example. So Comet is a language model that was fine-tuned on a common sense knowledge base. And you give it a sentence that describes a certain event, and then it can generate inferences along various dimensions. We mostly focused on actually, there's like event-centric dimensions and some like others. So for example, in this example, this is a failure example, we told the model that someone ate a Dutch baby. And I do realize from using this example recently that actually a lot of people don't know what a Dutch baby is, but you could kind of at least guess that it's a name of a dish and not an actual Dutch baby, because otherwise I wouldn't mention that somebody ate baby. But the model didn't understand it. The model actually assumed that somebody ate a literal baby. So it predicts that this person is seen as disgusting and mean. They then want to throw up, and they feel guilty, and others are sad and disgusted. So again, the reason this happens is very similar to like plain or like vanilla language models. This is based on the underlying language model is BART, which again was trained on English web text coming from mostly the US. Sorry, I didn't mention that Dutch baby is actually a German pancake. It does appear on the web. There's a lot of Dutch baby recipes, so I don't know why BART didn't learn that. But yeah, it's trained on, it's based on BART, which is trained on English text on the web, and it's then further trained on the atomic and concept net knowledge bases, which were both crowdsourced from, I think, again, mostly people in the US. So we recently developed GD Comet, which is the geodiverse version of Comet. After which I will explain in a second how we developed it, but if we feed person X eats Dutch baby into GD Comet, it now correctly predicts only neutral and positive inferences, like they were hungry and now they have a full stomach and they're full and happy, and others are now craving the Dutch baby. So this was actually a really simple model. What we did here, this is, by the way, I should mention, this is work by Meher Bhatia, my master's student. And this was published at EMNLP. And so what we did here was we took the underlying language model that Comet was trained on, which is BART, and we first continued training it in the same language modeling objective on the Kendall data set, which is a collection of automatically extracted sentences describing or defining all kinds of cultural concepts, like tofu is a major ingredient in many East Asian cuisines. And then once we had this BART model that is more culturally aware, or more aware of more diverse cultures, we trained it on the original data set that Comet was trained on. And just doing that really helped the keep the structure that Comet has, but also teach the model about concepts from different cultures. So we did two types of evaluations. The first one was an intrinsic evaluation, which is human evaluation. So what we did here was we created these inputs by using templates, like someone wears a certain clothes from a certain in a certain country, or like someone eats a certain dish in a certain country. So this is automatically created based on the Kendall data set. And then we generated inferences for these sentences using both the original Comet model and the GD Comet, our model. And we focused on 5 countries, specifically India, South Korea, Nigeria, Iran, and Indonesia. And we had annotators from these countries, 2 annotators from each country, annotate the inferences along the following dimensions. So the first one is cultural relevance, which is just making sure that the inference reflects the values, traditions, and norms associated with the particular culture. The second one is stereotype avoidance. So we want to make sure that the inference doesn't perpetuate stereotypes about the culture. And then the last one, linguistic accuracy, is just making sure that it's grammatical and uses like appropriate vocabulary and expressions for this culture. So the chart shows the average results across countries, and you can see clear preference for GD Comet, except for linguistic accuracy. Both of them are pretty good. This is from, I should mention, it goes from 0 to 3. Linguistic accuracy, we know that language models can generate grammatical sentences, so this one is not really surprising. But on the 2 other properties, GD Comet performs substantially better. There is some variation between the different countries, so if you're interested, I encourage you to look at the full results in the paper. We also did an extrinsic evaluation. So most of the data sets for measuring understanding of different cultures are actually, or like the 2 major ones are actually in vision and language. So we did evaluate on one of these, which is the GDVCR. So that's the geodiverse version of the visual common sense reasoning data set. There's an image, which is like a screenshot from a movie, and there are bounding boxes around different people in the image, and then there's a question about like what are they going to do next, or what is their motivation. Like, for example, in this example, what are person 1 and person 2 participating in? And in this particular culture, they are in a wedding, and it's divided to regions in this data set, not specific countries, which is a bit, maybe too coarse-grained, but yeah. So in the original paper, in the GDVCR paper, they showed that if you train models on the training set for VCR, which contains focuses on images from mostly American or Western movies, then the model doesn't perform very well on GDVCR, which contains only a test set. And so we tried to incorporate GD-Comet into a model for GDVCR. I maybe will not go into all the technical details. It's a bit complicated here, but we based it on VLC BERT, which is an existing model that was developed by my student Sahitia and a few collaborators. So this is a VL BERT model where you can incorporate external knowledge. In the original model, we used Comet for a different task. In this work, we wanted to show that we can benefit from incorporating GD-Comet. We can get better performance on GDVCR compared to using Comet or not incorporating any knowledge. Yeah, the way that it works is that we have a question and we have the noun phrases that we extracted from the image caption, and then we generate inferences for these noun phrases. I'll actually show an example in one slide. So this chart again shows the average across the 4 regions in the GDVCR dataset. And again, if you want to see the full results, they are in a paper. So the first baseline is just VL BERT, so it's a vision and language model with no added knowledge. The second one uses or generates inferences from BART model that was trained on the Kendall data, so the geodiverse data set, but not on Comet. So this one actually doesn't perform very well because the inferences are not as structured as the inferences from Comet. Then the third one uses Comet inferences, and then the last one uses GD-Comet. So you can see that it performs better than all the other models. Here's one example. So this is a GDVCR instance. The question here is, why does person 1 want a henna painting? And so VLC BERT with Comet failed on this one, but VLC BERT with GD-Comet predicted correctly that they're in a wedding. And you can see here at the bottom the top inferences from each one of the models. So Comet doesn't talk at all about wedding. It talks about wanting to buy henna or I don't know, getting a tattoo or going to the salon, but GD-Comet talks about getting married. And this picture I should mention is from Somalia. So GD-Comet was able to associate a girl wearing henna in Somalia with marriage, which helped it correctly answer the question. Okay, so this was the first project. This is the only one that is done and published. Now I'm going to talk about an ongoing project in which we collected collected a large-scale culturally diverse image captioning data set. So prior work showed that popular image data sets such as ImageNet are very Western-centric, and they mostly contain photos from the US. And there are several benchmarks that were suggested to test vision and language models on their understanding of images from other regions of the world. We already saw GDVCR. There's another one called Marvel, which is based on the NLVR dataset. So there are 2 images, and then there's a statement about them, and the goal is to determine whether the statement about the 2 images is true or not. And the original NLVR dataset is again focused on mostly Western images, but then Marvel has images from different cultures. It's also multilingual, but for the purpose of this talk, I'm going to focus on the English part. Sorry. So these are benchmarks. They're only test sets, and what we did is we collected a large-scale data set of images from diverse cultures, which can be used also for training. So in the first step, we took sentences from Kendall, again, the data set with the definitions of concepts from different cultures, and we Googled them and retrieved relevant images. That was pretty noisy. So we had a manual filtering of the images. Again, this is work led by Meher again. She did very like a lot of work on filtering out the data set. So here's one example. The traditional dance in Sri Lanka is as interesting as the country itself, and then we get an image like this. You probably noticed here that this doesn't look like a typical image caption. It's not as informative or descriptive. So to get a descriptive caption, we first asked GPT-4 to caption the image, just provided the image, ask it to caption it. So we get something like people performing a dance ritual with vibrant costumes and drums on temple steps. So that's very descriptive, but it's not as culturally aware as we'd like it to be. So then in the second step, we combined, we asked GPT-4 again to merge the initial caption that it suggested, like the descriptive one, with the sentence that we extracted from Candle into a concise caption. And we added the instruction to ensure that it includes the culture name and the concept words, and that it's not too long. So we get something like traditional Sri Lankan dance ritual with vibrant costumes and drums on temple steps. And this looks more like typical image captions. So these are the statistics of our data set. We have around 60,000 images with captions across 47 countries and 14 religions. The distribution is drawn on the map. It's not perfect, but it is pretty diverse. I also it is split to train, test, and validation, but I don't have the exact numbers for the different sets. So the first thing I can do with this data set, if you take the training set, you can use it to train VL models to become more culturally aware. And so we did that. We have a model that's based on TCL, which is a vision and language model. We're using the original training objectives. We did make some changes, but I won't go into that. So it's mostly a masked language modeling objective. So you have you're hiding some words from the image, from the caption, and try to predict them, or hiding some regions from the image and try to predict them. And there's image text matching. So you want to know that a certain image goes with a certain caption, and you have to be a bit careful about how you choose the negative examples. So we chose them such that it would be hard. So it's from a different culture, but having like similar objects. So we trained this model, and now we have 3 tasks so our test set has 3 tasks that could be used for models to evaluate the cultural understanding of the models. This part is the ongoing work. So I don't have, we're still creating the tasks themselves. So the first one is a retrieval task. So we want to, the input is culture specific concept like dosa. And then the goal is to retrieve images from the data set that correspond to this concept. And then the models are tested on their precision at K. So how many of the K top images actually correspond to the concept. And each concept would be associated with a particular culture, so we can actually compute the precision per culture. And ideally, you want the models to perform equally well in all cultures. The second task is also a trivial task, but in this case, where the target is a general concept like wedding or breakfast, and the models are tested again on their precision at K. So we want to make sure that the top images that we retrieved are indeed like wedding images, but we also want to measure the diversity. So we want the top K images to be from diverse cultures and not just like mostly, like Western weddings. And then the last task is the task of referring expressions. So here the input is an image depicting a certain ritual like wedding, and a text describing the element in the ritual, like for example, a bride. And the goal is to draw a bounding box around the image region that corresponds to this element. And the models are tested on their overlap between the gold standard bounding box and the predicted bounding box. So it's intersection over union. And again, we are going to measure the performance per culture separately, and ideally they should perform well on different cultures. So this is still a work in progress. We're still building these or like finalizing the test sets, and then we're going to run some baselines and see how well models do on this task. Okay, and for the last part of the talk, I want to focus more on our future work. It is something we started doing, but it's still at very early stages. So the idea here is that we want to, so everything that I showed so far is just about familiarity with concepts from different cultures. And we want to actually take a step forward from teaching models about concepts from different cultures to teaching them to view the world through the eyes of individuals from different cultures. Like when we communicate and we have our own background, and that's how our own lens, cultural lens. So I'm going back to the tipping story, and just to remind you, ChatGPT in the, I don't know, April 2023 version thought that this couple was frugal because they tipped only 4% in Madrid. But then when I added the information that in Spain tipping is optional and not very common, it was able to reason about that correctly and said that tipping 4% means that they enjoy the service and that they are kind. So this means that being able to identify the relevant cultural norms and maybe expressing them explicitly in text is a promising direction. So for example, we would like the model here to first be able to recognize what is the underlying situation. So for example, here, the situation is tipping 4% at the restaurant, and then condition on different cultures, we can generate social norms, such as if we're conditioning on the US, it's very rude to tip less than 15%, even if you got a really bad service. But if we're conditioning on Spain, then it's actually kind because tipping is optional. We're now trying to collect a data set for this, and one of the first problems we ran into was that collecting narratives from different cultures. So you can start with, like, if you start with English narratives and you just ask people to come up with the narratives, they're already going to be biased towards the culture of the annotators. So what we did was we collected narratives from movie plots from English Wikipedia, but from movies from different countries. So the plot is quite long, so we also asked GPT-4 to summarize it into like a 5-sentence narrative, and we gave it some specific instructions like only use the first names of the characters, avoid location names. We basically just wanted to reduce the recognizability of the movie by models. This is where, it's really like ongoing work. We don't really have a task yet. So we could potentially do something like ask the model to generate social norms that are evoked by this narrative. So maybe, I didn't read this narrative. This is from a movie from India, and here are the cultural norms that were annotated by Meher. So she said it is the duty of the child to take care of their parents, especially in old age, and the child must always respect their parents. We could ask models to generate these social norms, but then it gets tricky to evaluate that other than human evaluation. We don't really have a good way to do that. And we also, we've been collaborating with a large group of people at the University of Washington and at AI2. Everyone has like different ideas about the task, but we couldn't settle on a good task yet. So if anyone has the ideas, I'm happy to discuss it during the lunch or break. And now I do want to make a general note about this whole talk about working on culturally aware NLP. So one question that we can ask here is, can't we solve the diversity problem by training large language models for languages other than English? So the answer here is yes and no. So first of all, languages don't perfectly map to regions of the world. So there are a lot more languages than regions. And as you know, I always give the example of like, we're in Canada and there are two official languages, English and French. But when I'm in Vancouver, there are almost no French speakers, but there's like a 20% Chinese speakers, and it's not an official language in Canada. So there's definitely not like, and also, as I mentioned earlier, there's a huge population of English speakers outside of North America. They're not well represented by English language models at the moment. And so we could think of going like finer grained and training models for dialects or regional dialects. But that becomes at some point infeasible in terms of the data size, because we will run into the problem of not having enough data for certain regions, and then the models would just not be of high quality. So overall, while it is important to keep working on multilingual NLP, this should probably be done in parallel to improving the cultural awareness and sensitivity of models. So the second point is that there are many users whose native language is not English that still choose to use the English language models. That's because, significant breakthroughs in NLP tend to start with English before they are transferred to or applied to other languages. And even then, many languages don't have enough text online to train high quality LLMs. So eventually, due to either lack of availability of LLMs in their native language or the superior quality of English language models, users from different countries and backgrounds may prefer to use the English models. So to recap, culture plays a significant role in shaping our communication styles and worldviews. And English language models suffer from North American bias because of the source of their training data. It is important to address this problem, because if these models are used for downstream tasks, they may result in discriminating against people from different cultures. I showed several works, the first two in which we provided models with knowledge about concepts and traditions from different cultures in both language and language and vision, and ongoing work on teaching models about cultural norms. But this is just the tip of the iceberg. There's so much more to teaching machines to understand individuals from different cultural backgrounds. So thank you, and I'm happy to take questions. Yes.
If you go back to the slide shortly after we went to section 2, you had a graph with, I think, a Sri Lankan wedding, and then the text went into GPT.
Yes.
I thought this is a very clever approach, and I'm just kind of curious about your kind of qualitative sense of, when you go through this approach, like how, what kind of variation do you get on the final text at the end? Like, are there any topics or situations or maybe aspects of the image that might constrain or loosen it up?
So that's actually to be done. We need to do a human evaluation on the captions. So we actually, for a long time, we just used the sentence from Candle as the image caption. But at some point we thought that this was too different from the typical image captions. And if we continue training a vision and language model that is used to like a more descriptive caption, that would that might be like lead to like suboptimal results. So we ended up doing this rephrasing with GPT-4. But we still need to, I mean, from just looking at some of the data, it seems really nice, really high quality, but we still need to do some human evaluation, and we'll probably do it also for like a sample of the cultures by people from the culture.